I will look at the last video of this section and this chapter. So graph of y equals cotangent x and its variations. So the point is that a cotangent is 1 over tangent. So when you flip it like that, if x was, or if the graph was getting really big, now 1 over there, it's going to get small. So we get this reflected graph. Excuse me. So that's the graph of a cotangent. I mean, if you think about it, where sine is 0 is where you're going to have asymptotes. So we have at negative 2 pi, negative pi, 0, pi, 2 pi. And think about the quadrants. So like from, let me go over here. So from 0 to 2 pi, cotangent's positive, but from 2 pi to pi, it's negative, and hence it goes down like that. From pi to 3 pi over 2, it's positive, but from 3 pi to 2 pi, it's negative, so it's going down. So what was different about the tangent is the asymptotes were at pi over 2 and 3 pi over 2. And so that's why it was going up as you go to the right. These are going down as you go to the right. Okay, so how to graph the period, one period of the function. You have your stretch factor of absolute value of a. And these are really kind of hard to see because they do go up and down forever. Your period is, again, back to pi over absolute value of b. Your phase shift is c over b. And draw the graph of, let's just say cotangent. bx shifted to the right by c over b and up by d. Sketch the asymptotes, x equals c over b plus pi over absolute value of bk, where k is an integer. Plot any 3 reference points in graph. So let's start with our first one here. We know what our a is. It's going to be 3. That's our amplitude. So that's our stretching factor. Now normally this would be at, as we said, on the pi's, 0, pi, and so on. Let's see what this is going to be. So it's going to be pi over b, which is 4. So that's our period. So I'm going to relabel this graph. So we have period of pi over 4. And there's no horizontal shift, so this x equals 0 is still going to be 1. So I'm going to call this pi over 4. I'm going to call this pi over 2. I'm going to call this negative pi over 4. Call this negative pi over 2. And then we would have an asymptote here, an asymptote here, and an asymptote here. Now, so the crossing point, like let's put pi over 4 in here. What would y equals 3 times cotangent of 4 times pi over 4 be? That's going to be 3 cotangent of pi, and cotangent of pi, so that's going to be cosine over sine, and sine of pi is 0. So I just messed up on my asymptotes. So it's going to be undefined. So let me change that. I could delete that and not let you know I made a mistake, but we can learn from my mistakes. I'm glad I checked that. Okay, so pi over 4 let me just think about this for a second. So it's at 0, what is it going to be? We're looking at cosine over sine, so sine of 0 is 0. So it's going to be, that should be an asymptote, right? and sine of pi is 0. Oh, yeah, our period's pi over 4. What am I thinking about? Of course, so we'll have a vertical asymptote there. And one here. And one here. And one here. Okay. Now, let's go ahead and graph. We know the middle of that is a crossing point. Middle of each of these. And then we know between, here, halfway in between, it should be at 1. But we have a coefficient, leading coefficient of 3 as our multiplier. So there, and we're going to go down. So we'd have a graph that looks something like that. Ugh, that looks bad. I try to fix it, but drawing on a computer screen is not my strength. And there, and there. And there, and there. Okay, so we have our curves. And there's our graph. So our stretching factor is 3. There's no phase shift, but we do have a period of pi over 4. Okay, well, I'm glad I could probably edit that out, but I think maybe thinking through it could be beneficial to students. Okay. Sketch a graph of one period of this function. And so here we have cotangent of pi over 8, x minus pi over 2. Interesting. I mean, right off, I'm curious about this phase shift being pi over 2 divided by pi over 8. So I believe that's 4. That's really interesting. Our a is 4. So that's our stretching factor. Our period is going to be pi divided by pi over 8, which is 8. Okay, that makes me feel better. I was afraid our phase shift was going to be more than our period. And then we have a vertical shift of -2. So it's going to go down 2. So when I do those, those points where I'm in between, then I'll be able to say, like the halfway ones, whether it go to 1 or -1, I'd go to 4, -4, and but I'll then have to shift everything down by 2. Okay, so 0 to 8, that would be our period. I think, did I make this? I think I tried to go to 16. I didn't quite make it work. I got the phase shift to worry about. Okay, it would be 0 to 8, but we have a phase shift of 4, so we're going to be at 4. Then 8 plus 4 is, oops, no, don't do that. I'm really glad that there's something on the screen for me to accidentally tap while I'm trying to do my video that would crash the whole thing. That's wonderful. Okay, so there's our asymptotes. We have our crossing in the middle. Oh wait, got the -2. So I got to shift that crossing down a little bit. If you don't mind, I'm going to do this. Go back to draw here. So it's going to cross at -2, which is right there. And then halfway in between this center point and then the asymptote would have been at 1. Then we multiply by 4 to get to 4. Then we subtract 2 to get to 2. And then likewise over here, halfway between 8 and 12 is 10. It would have been at -1 there. Multiply to get to -4. Subtract 2 to get to -6. So I believe our graph's going to look something like this. Okay, There's our graph. How fun. Okay. And I believe that's it for this section. Another pretty long video, so sorry about that.